Hey, physics. Going to give you a quick tutorial how to do this lab with this circular motion exercise here. You're going to go to Pivot and find the circular motion lab. And then you can see this kind of cool setup here. Just going to go ahead and play here for a sec so we can see what is actually going on here. So there's this rotating platform here. And you can see there's this little mass going around in a circle on it. And there's a pulley here. Why is there a pulley and what's this? So this is a force meter. It's like a scale, basically, like a spring scale. And the pulley is only there to redirect. So if I move that to here, you can see for something to move in a circle, circular motion doesn't happen for free. It turns out you need to have force toward the center of the circle to make it happen. So the pulley is only here to just redirect, so we don't have to have a scale that's also spinning around in a circle. That would be harder to read. So make no mistake, this scale right here is not measuring a downward force. It's really measuring the force pulling in on this mass as it goes around in the circle. And the pulley is just to redirect it. And so we can have the scale right in the middle there. It's a pretty cool setup, I think. What we want to do, if you read the directions, you're supposed to come up with 3 data tables and 3 graphs to go with those. And the first one we're supposed to do is we're supposed to vary the mass. So I'm going to go ahead and click on change here. And you can see you have a choice whether you want to make the mass tangential speed or the velocity of it or the radius. Which one of those do you want to be the independent variable? And the first thing I want to do is vary the mass. I'm going to make that the independent variable. And then what this is going to do, it's just going to show you if we're varying the mass, then you don't want to change these 2 things. So it's just going to show you which ones you can choose from. The grayed out ones are ones that you can't choose, and the other ones are ones that you can't. I think that that's right. Let me just try that. Yeah, the grayed out ones, you can try clicking on them, but nothing happens. So you can choose any of these 5. You just can't change it for the rest of this part of the lab because we're going to be changing the mass. So whatever you choose, you need to leave it alone after that. So I'm going to go ahead and click that. And looks like I only have one choice for the radius. I'm going to click that, and then I'm going to click load. And it's not letting me do that. Why not? Let's see. Doesn't like that combination of things, I guess. Let's see. It's not showing me. I'd like this to go away so I can see that. So I think, oh, there we go. Okay, so now I've got my tangential speed set, my radius is set, and I should be able to change my mass. And I'm going to need to change that mass to all 4 of these options. Notice that I'm not messing with these. So if you have the same problem that I did, you just choose something different. But once you set the things that you're not going to be changing, then don't change them for the rest of that part of the lab. So let's go through and just figure out real quick here. So I'm going to go ahead and play here. And I'm going to look at the force sensor, and it looks like that is, now be careful here, this is 0.1, this is 0, and this is 0.1, and this is 0.2. So these go up by 0.02, right? This notch right here would be 0.1, and then these are 1, 2, 3, 4, 5. So these go up by 0.02s. So this would be 0.08 right here. So the first thing I'm going to do is I'm going to make my little data table, and I'm going to insert a table, And let's see, it looks like there were only 4 different masses there. So I think I only need a 2 by 5 table, right? So at the top of this will be mass. That's what I'm varying. So I put that first. And I would like that to be in kilograms. I'm going to do that conversion on the fly. And then here I've got force measured in newtons. And for the first mass, it was 20 grams, so that's 0.02 kilograms. I have the units up here at the top, so I don't need to put that here. And then the force was 0.08 newtons. I'm going to go back to this, and I'm going to change it to this. So there's my 50 grams, and I'm going to crank that thing up again, and then I'm going to let you finish that. So that's how you get those. Only going to have 4 data points because there's only 4 to choose from here. That should be just fine. Then you're going to go, and the second one I asked you to do was to make the speed the independent variable, right? And so there's 7 choices for speed, and your only choices for these, you can either use the 20 or the 50, pick one of those, and then it looks like we have to choose radius D, right? Choose those, and oh, that's why it's not clicking load. That's the problem I had. I had not chosen one of these yet. Okay, so that should be good. And now I want to do all of these speeds. And now I'm going to need some measurement tools here to get the speed of this thing. So that's going to be a little bit of a trick. So I need to measure the radius of this circle, and that dropped that in like just in the right spot. That's the center right here, right? And this looks like it's right at 30 centimeters. So how do I figure out how fast it's going? Well, it's traveling in a circular path. So here's what we need to do. When something's moving in a circle, let me just get out of this data table here. So the next thing that you're going to have in your document, sorry to interrupt myself, is a graph of force versus mass. That means force is going to be on your vertical axis, mass is on your horizontal axis. Okay, and then I'm going to have another data table, which I'll insert here in a minute. And now you don't need to put this in your document. I'm just going to kind of type a little bit of notes for you here. If something's moving in a circle, then it goes all the way around the circle in some amount of time. So we could say that the speed of it for something moving in a circle is equal to the circumference of the circle. That's how far it is around the circle, 1 lap. Remember what the circumference of a circle is? 2 pi times the radius of the circle. And divide that by how long it takes to complete 1 lap. That time, something that is periodic, like happens over and over again, that we call that the period of the motion. That is how long it takes for 1 lap. So we use a capital T for that, but I'm just going to type that period there to make sure you understand what that stands for. So that is how we're going to find the speeds. All right. What am I going to put in my table? Why don't we do it like this? I'm going to insert my table. And this one, I think there were 7 choices. So I'm going to make a 2 by 8, but I'm actually going to make a 3 by 8 because what I'm going to record here is I'm going to record time. Will be in seconds. And then I'm going to record speed, which is equal to 2 times pi times the radius, all divided by time. If I have my little calculation right there, so I can show my my reader exactly what's happening here. So I'm going to take whatever this time is, I'm going to do 2 times pi times the radius divided by time. And then here I will have the force, reading of the force sensor. So let's just run through one of those real quick, make sure that we're good. Go back to my pivot video here. Looks like the radius is 30 centimeters or 0.3. And I need to figure out how much time it takes for one full lap. So it looks like I'm going to start here and then see how much time it takes to get back to there. So there's my 0 time, and all the way around we go till it gets back to right there. So it looks like that took about 3.9 seconds. Okay, so I'll record that. Was it 3.9 or 0.39? 3.9 seconds. I guess it's going pretty slow. This is setting number 1. Okay, so 3.9 there. And then my speed, I'm going to do in my calculator. I'm going to do speed is 2 times pi times the radius of the circle, which is 0.3. Please make sure you convert your centimeters to meters, divided by the time, which is 3.9. Right next to it. So the 2 pi times 0.3, that part's going to be the same every time because we're not changing the radius. So that's what I'm doing right there. And that gives me a speed of 0.48. And then I forgot to look at the force sensor to see what the reading was there. It looks like it's 2 of these notches. Remember, each one of these notches is 0.02. So this is 0.04 right here. Okay, 0.04. And then I'm going to go back to the video and I'm going to go to change. And I'm changing the speed here and leaving these things the same. So I'm going to go to speed number 2, load that, and everything, the radius and everything is the same. I just need to figure out how much time it takes now for it to go around at the speed of the plate has been cranked up a little bit. And then I need to find the new reading on the force sensor, which looks like about 0.07, right? In between 0.06 and 0.08. So that's what you need to do, and you do that for all 7 of those. And then you're going to go back to your Google Doc, you're going to make your graph and graphical analysis, all that, and so graph here, graph of force versus speed, and then you're going to do your last data table, which is varying the radius. And that should be easy for you to do. I think this was the tricky one, how to get that speed there. So I don't think you're going to have any trouble here. We'll just go back in real quick and say if we're going to make the radius the independent variable, then here's my choices. Only one speed to choose from, and then you can choose the 20 or the 100, either one. And then you got 5 of these radii to choose from. So if I chose A, I'm going to go load here, and it looks like this is the real short radius. So it looks like the mass is just only about 5 centimeters, right? I'm measuring like the middle of the mass there. You can look at it on the other side of the circle if you want. Also, yeah, I think that looks like 5 centimeters measured right to the middle of the mass there. And so that'd be 0.05 in your data table. And what's the reading on the force sensor? it looks like it is this would be 0.7. This is 0.72, 0.74, 76, 78. So I would call that 0.79. It looks like it's right in between those. Hopefully you don't have too much trouble reading that diagram there. And I think that that is all that I need to show you. So we're looking for 3 data tables. After each data table, it'll be the graph that's associated with that. And then answer that last question that's described in Google Classroom. And you should be good to go. All right. I'm going to turn this video off. See you later. Oh, hold on.